Just as the foundation is built and the basic structure established, we next need to tie things together to ensure that all of the many pieces making up the house fit together well, and thus allow the house to serve its purpose. There are 4 sessions to address this point. In Session 7, we will learn ways to link processes together and study approaches for continuously improving our work using standards. In Session 8, we'll study the new role of transportation in developing a streamlined flow of materials. In Session 9, we will evaluate the role of suppliers and think about ways to develop a goal congruence between manufacturers and suppliers. In the final Session 10, we will reach the last and perhaps the most important benefits of running an excellent manufacturing operation, and that is people. How people and techniques are tied together to improve operations continuously. As we discussed before, small lot production offers many benefits to a company's operation. Even if reducing the setup time and making it an everyday event takes some effort, the benefit will more than compensate for it. As we said before, when we practice small lot production on the assembly line, we call this mixed model production or simply mixed production. This is because many different models are assembled on the same line in a mixed fashion every day, every hour, or in some cases, every few minutes. This is an example of mixed production practiced at a Japanese refrigerator manufacturer. As you see, there are big and small models of refrigerators assembled, one after the other, on the same line. Here at Fireplace Manufacturers Incorporated in California, various models are not only mixed over the period of a week, but over the period of a day as well. By practicing mixed production, customer demands can be met more quickly, finished goods inventory kept lower, and a fine-tuning of the product mix made easier. Hence, the risk of overproducing any unnecessary products is reduced. Furthermore, since the variety of parts consumed every day on the assembly line is a fairly steady mix, the upstream processes are able to control production more readily than with the traditional mode of production. While mixed production will make the total production activities much smoother, sudden changes in production volume will still have a negative impact if they are not managed well. This is why leveling the total production volume becomes important. Because of this trait, it's called level production. This can be practiced in the shipping department, for example, to help level the workload.
The material handling business planning team viewed elimination of waste in their area as a primary responsibility. Since we wanted to know if specific actions achieved desired results in that area, we needed to develop a means of measuring the volume of activity in those departments. This basically is the check portion of the PDCA cycle. In the shipping department, those folks selected to use lifts per man-hour as the most appropriate measure for their work. It was certainly a choice that they made because they know their work better than I. This was the chart that they made as a result of that work. This is lifts per man-hour charted for each day. This is for the months of the end of the month of February and the month of March. And you can see that there's a substantial amount of variation in this chart. Excessive variation in any operation usually translates into waste. And in this case, we can see that towards the end of the months is the area of peak activity, and earlier in the months, there is less activity. The question was, how do we go about, in their minds, was how do they go about making that a more uniform distribution of work throughout the month? The shipping people went to the production planning people and said, why do you always ship certain things towards the end of the month? That was one of the major features in this fishbone that they did to try to determine the cause of variation in their department. And holding material till the end of the month to ship it was certainly a significant cause. Production planning and shipping worked out an arrangement with several customers that postponed or did not postpone shipping of all material at the end of the month. Instead, it spread it out throughout the month. And as a result, looking at the month of April, this is again as the end of March, looking at the month of April, we see substantially reduced variation over the month. Here in the second week is just about as busy as the last week. The third week is pretty close to busy as the last week. First week still down a little bit because of the big shipment at the end of last month. The indication of this, well, what this means is that through their own thinking and their own application of the business planning process and the PDCA cycle, they were able to identify an area of waste in their department and eliminate it.
When level production is established, we can expect final assembly to complete a product at a certain interval, such as 1 minute per unit or 1 hour per unit. In fact, the whole factory may start to develop a rhythm corresponding to the final assembly line. Since we do not want to overproduce products, leveled and mixed production will make the waste of overproduction more visible and easier to address. This rate of production, or that time between the completion of the last product and completion of the next product, is called cycle time. In Japan, this is called takt time, reflecting the rhythmical swing of a conductor's baton in an orchestra. As in the case of the music played by the orchestra, if we can use this cycle time as a tool to expose problems, we can focus our efforts on those areas and facilitate further improvement. Just as cycle time can function as a yardstick to help us improve our factory, we have learned other tools in previous sessions that may have a similar function. We call these helpful yardsticks our standards. Not in the traditional meaning of standards, but as a tool to make the whole factory more competitive and for everyone to benefit. Without such standards, our improvement potential is very much limited. Things will fall back into a chaotic state, leaving only the firefighting work left for us to do. Naturally, it requires discipline. For example, we can't maintain good housekeeping in an environment where people drop trash and don't bother to pick it up. Setting standards is a fundamental part of continuous improvement. In order to improve, we must set standards and practice the concept of management by exception. For each exception to a given set of standards, we need first to solve the problem, and then improve the standard so that the same problem does not occur again. The more we improve the standards, and the more people develop the skills necessary to meet the standards, the more we can move forward. This also means that with more standards in place, the more jobs we can do, with less confusion.
The original way we were doing the training on the line was to rely on more experienced assemblers to train a new person to do the assembly of the part. And we ran into a number of inconsistencies there. And what I did at this point is, looking at the animation tools that were then available for the Macintosh, I took the procedures and basically did like technical drawing animations showing each procedure, how each part would go into each other and in what order that they would occur. And we then have these running out on the line, and it adds a consistency to the performance of the procedures, and anyone at any time can refer back to that and do the correct steps in the proper order.
This cycle of continuous improvement can be depicted in the following fashion. 1. Study the current operation and standardize the work procedures. 2. Find the problem areas. 3. Solve these problems and develop improved methods. 4. Implement the new methods. And 5. If these new methods are satisfactory, develop a new work standard. And continue the cycle starting from number 2. As we discussed for developing a plan, do, check, action cycle, which is in essence the same as this cycle, standard work can't just be something that the staff or supervisors demand of the operators. The whole idea is to involve everyone, including supervisors, in the development process.
Any other cells that we've done have been done with total operator involvement, and that's the key to making this thing work.
Up to this point, we've discussed the major elements of production, from housekeeping to scheduling, and from flow production to quality and maintenance, all driving toward developing the momentum necessary for continuous improvement. Now, let's see how we tie these elements together. If we compare a factory to a symphony orchestra, we find that a well-performing orchestra has similar characteristics to that of a well-run factory. Each musician has skills that are well developed through extensive training. Each instrument has its own tone and is tuned and well cared for by each player. There is also a conductor who interprets the music score and coordinates the efforts of all players into a polished performance. There are three basic elements in music, that is rhythm, tone, and harmony. Our factory operation also requires three similar elements. As rhythm in music drives the whole orchestra to synchronize with the swing of the conductor's baton, cycle time in a factory will drive the production line with a smooth, steady flow of goods. Tone is, as distinguished from noise, a beautiful sound coming out of musical instruments. This is compared to machines producing good quality products. Only by practicing good maintenance and quality at the source will a factory produce the desired output. Harmony, then, is the coordination of individually different sounds. Just as an orchestra cannot perform well if each individual player is concerned only with his or her performance, the coordination of different operations or line balance in a factory is key to its well-integrated performance. The music score for each musician is similar to standard work in the factory. In our factory, standard work is a tool to achieve maximum performance with minimum waste. Only when all of these different elements fit together can the whole orchestra produce an outstanding performance with beautiful harmony, tone, and rhythm. No single element should be missing. No single player or instrument should be out of tune or music score missing. In manufacturing as well as in music, the well-coordinated efforts of people and techniques can produce unbelievable results.
I'm beginning to understand what you're trying to convey with the orchestra analogy, but regarding the leveled mixed production, are you trying to say that we need to develop a rhythm in manufacturing operations?
Yes, and with no big surprises. We'd like us to see the operation similar to the performance of an orchestra or the ballet. Better coordination and no waste in the performance. Not like an ice hockey game.
So everything should fit together, but this will require people's dedication, won't it?
Yes. Any impressive performance requires a certain dedication for practicing it. But when accomplished, there will be satisfaction in that we did our best.
I have a question about the cycle time and standard work. What do you do with the job shop style of manufacturing?
A good question, but you can still think of things you do repetitively and practice in such areas, perhaps housekeeping, procedures for using tools, order taking, production planning and control, and so on. There's always some kind of rhythm in any business that we can set standards for and improve upon.
I see.
Just-in-time production means producing the required parts at the required time in the required amount at each step in the production process in the most economical manner. To practice this, processes need to function as if they were connected by invisible conveyors. This requires developing a just-in-time information and control system where all necessary information arrives on time at the place where action is to be taken. Kanban, which means display card in Japanese, is one such production control tool. Here is an example of Kanban practiced between machining and assembly operations.
It's what we call a two-bin system or a Kanban system. And basically the way it works is that for every part that we machine in the machining cell, we have set up two bins. What happens is that the assembly operator will take parts out of one of the bins, and when that bin is empty, he will hand it back to the machinist. And that operation gives the machinist the signal to make more of that particular part. Now, the effect that this has is that it links the assembly operation and the machining operation very closely. And the total control of the whole process from start to finish is put in the hands of two operators. That's the fellow from assembly and the machinist. Now, when we compare this against the way we did it in the past, is that under the MRP system, all these parts would have ended up in stores, in finished inventory. And the signal to withdraw more parts would basically be a work order that would come down to the shop. We would have to put material requisition slips through the stores to get the material out. There was a lot of handling, parts going to and from stores, and a lot of wasted effort. But this system here, the distance that the parts travel is only a matter of 20 feet. And we don't need any outside control whatsoever. The whole control is basically in the hands of these two operators. There's no influence by the computer, anybody from stores, supervision, or anything. The whole system is self-controlled. I'm standing at the other end of the Kanban rack that we described earlier on. And as you can see, the way that it works is that Tom here in assembly takes whatever parts he requires to make up the finished product directly from the boxes. Each one of these boxes, as I said earlier, is uniquely identified, so it identifies the part that he requires. And all he does is simply just remove whatever he needs for the assembly and puts these parts together. Now, once that box is empty, as I said before, Tom will just take it round to the machine shop, and again, that will be the signal for the machine cell to make those parts.
This shows what the people at Hewlett-Packard call a Kanban square. It functions much the same way.
You'll notice that everything is well marked on the floor, and it's also labeled, so we know where everything is. It provides also for easy training and understanding by the people who work in the process. If we look down here, we can see the line where they build both the Series 70s and the 850s, 950s. So what you see is a mixed model line. We're building 2 different or 3 different computers on the same line. And you'll see the blue squares on the process. Computers are worked on while they're in the squares, and the next blue square pulls a computer into the next process. You'll also see behind me that all the material here is actually stored online. So everything you see in the bins, everything that needs to be done at this workstation is here behind the person who's building. And we have no warehouse, so everything that's here is stored online. So the workers can actually see and monitor when the stores are getting low, and they have some control over their own inventory.
At Apple Computer, carts are used as Kanban.
As you can see to my right here, this is the new carts that we have established here at Apple. We used to have carts which you would have to take the material out of each individual box, place it onto a cart, and send it to the assembly line. Now we've instituted a Kanban theory and method here, which we have basically 3 carts per each product that you have to send to the line. 2 carts are always out on the line at any one time. A 3rd cart is back here, always being filled. As you can see, there's boxes on the carts now. We have gone to the new method. Instead of having to individually unpack every item, we now just take a box directly off the skid, put it onto the cart, send it to the line. People out there take the parts out that they need, send the cart back with all the packaging. We then break down the packaging and we reuse it. This enables us to lower our material costs. As you can see the sign on the cart, this is what a Kanban is. Basically, it's just a sign telling you what there is, quantity, parts per box. If you look at this and you were to count, this is exactly what is on this cart. We have also established a quantity per cart, which is basically that material is used within 1 hour. All the carts that we use on the line, we've basically gone to 1-hour sequences, which is a lot easier to control from an engineering standpoint. Also, with this new Kanban theory, as you can see, it has definitely really helped the organization back here and the inventory control. Our accuracy has gone from about 75 to 80% to almost 99.9% accuracy in this specific department.
The system that Apple has, I think it is very good. It makes the production line go a lot faster, a lot better, a lot smoother. The way that we do it is, once they empty out a cart, I got to go and bring a full cart up right away. Like I said, that system, it enables the line to go faster, smoother, and better.
At Fireplace Manufacturers Incorporated, employee suggestions help their Kanban efforts function even better.
There's literally over hundreds of Kanban cards in the FMI shop to supply our 14 different models of fireplaces that we currently produce here. Each item that you'll notice different two different colored dots. We work on an average of 2 to 3 days of the work in process, allowing that 2 or 3 days to replenish our supply of work in process back over to the assembly line. Specifically, we have at the very top of each Kanban card is the FMI Kanban number. This lets the operators know of each department if they need to check a print, they will look up that specific part number. It then goes down to the lot size, and this particular part number is a lot size of 52 pieces. The minimum inventory then is a minimum of 26 pieces. We've taken this average from a history, thinking that 26 pieces allows us the time of 2 to 3 days to replenish once again our work in process supply back over at the assembly line, so we do not run out and cause a downtime on the assembly line. We then move down to the routing, which is a very important part. So each employee of the FMI work in process and the assembly line knows the routing of the material. This particular part, it will be sheared naturally. It will not be sent over to the punch press part where it will be stamped out, but will be sent directly to the press brake area and then over to the glass door department where the work in process will end up at. Another key that was from a suggestion of an employee over a year ago is that we have yellow and white Kanban cards. These yellow and white Kanban cards specifically let each operator know of particular machines, as far as employee education goes, that they know that this particular card, yellow, that it is aesthetically important. It's very, as far as any marks along the face of the material and so on, needs to be absolutely perfect with the tolerances and so on. Whereas a white Kanban card, a mere scratch on the surface of the material is not going to affect the actual parts or the aesthetics of the fireplace or the working of the fireplace, the abilities of it, and so on. After it leaves the shear department, we'll move over to the punch press department, then over to the press brake department once again, then to the assembly line, where we will resupply the stock of the work in process. Where we are now, we're at the destination stage of the work in process system. You'll notice that the racks alongside of me have the Kanban cards actually on them, and you'll also notice a couple of racks that do not have Kanban cards. These parts here are being ready to be sub-assembled, where they'll be put directly on the assembly line and then routed to the warehouse. These particular cards here, you'll notice the actual card is on the actual minimum here. This particular item is 40 pieces. This is on the actual 40th piece, but when it hits this, the operators, the welders, the sub-assemblers know that they need to take the card off, send it back over to the shear department, where we've allowed ourselves an average, once again, of 2 to 3 days to go ahead and replenish the supply of material. Also, you'll notice that behind me, this particular rack behind me with the red mark on it, that is another suggestion of an employee where we painted the actual stationary item in case a card gets knocked off or falls off the material and so on, that we know specifically where the actual minimums are and when we need to go ahead and cue ourselves to go ahead and send the card over there where we begin our work in process system. All these particular racks have been dedicated to these specific parts. You also notice the actual labeling of the racks with the specific parts. This is once again part of the organization, a very key part of the organization, of having a place for everything and everything in its place, and the dedication of the specific parts of the work in process and the Kanban system.
At Toyota Auto Body of California, the employees find it easy to practice Kanban.
Between our press shop and the assembly welding operation, we use an in-process Kanban. To give you an example of how that works, every container that we fill with parts, we attach a Kanban ticket. In this case, the container will hold 40 pieces. The guys in the press shop will fill the container with that 40 pieces, attach the Kanban ticket, and send it to the welding operation. As the people in the weld shop use those parts, the tickets will come back as the containers are emptied. Every hour they're placed on the board. In this case, we hang 1 ticket per hook. In a case like this, we hang 2 tickets. It depends on the size of the parts and the size of the containers. When the tickets come back and they're put on the hooks, when they come out to the end, the press shop knows that they have to begin to manufacture those parts. Nobody tells the press shop what to do. It's just a continuous flow. As the tickets come back, the press people will start to manufacture those parts. Also, by looking at the Kanban board, we can see that in this case, very quickly they will begin to run. In this case, also very soon they will start production. In this case, either the parts were just made or they're getting ready to be made. So the visual control is very good. We can walk by and look at the Kanban board and we can tell what our inventory status is. So the Kanban system has many benefits for us. It's very simple, very easy to control.
Our final comment regarding Kanban is from the production manager at Flowjet Corporation.
6 months ago, we started the GIT Kanban system in our shop. The other day I was walking through the departments, and to my surprise, I noticed some different racks in our shop. And these were the racks, the Kanban racks. The supervisor took his spare time and made a sign at his house, as noticed right here. It was a very nice surprise for us, and what can I say? Kanban works.
One thing interesting to note here is that the Kanban concept was developed by Taiichi Ono from Toyota in the 1940s after learning about the American supermarket system. This is a pull system. As goods are pulled according to the needs of the customer, we replenish them. Since we've discussed the concept of the next process is your customer, we can apply this concept of a pull system all the way back through all production phases to the purchase of the raw material. Sort of like a chain reaction taking place when the customer initiates the first pull.
I see there are variations of Kanban, but is Kanban everything we need to know?
Not necessarily. The idea is synchronized production or flow production, where everything fits together. You can use different tools. For example, using an electronic means of conveying production or inventory information may be an idea. But simplicity is something we must not forget.
How do you determine the quantity on Kanban?
Well, there's a formula, but first I might recommend using your judgment to set the quantity that you feel comfortable with. Then reduce the inventory, as we discussed before, by reducing the quantity on Kanban.
Then expose the problems and solve those problems and then keep working on it.
Yes, you're right.
In a job shop, what may be a good tool?
Well, in a job shop or any business where demand swings are big, Kanban may not be the ideal. But putting up a simple and visible board or improving the flow in the shop by rearranging the machines will be a great help.
I see.
Several years ago, we implemented a computer program to try to manage our inventory and actually to implement full manufacturing resource planning. And I'm sorry to say that that has not been real successful. Lots of consulting companies came to us, and of course the computer manufacturers, and told us this would be the answer to everything. And with my normal Western mentality, it's all seemed to be logical and make sense. They said that they could integrate everything we needed to do into a nice big system that would print out all the steps that needed to happen, and everything would be figured out for us. And it was very logical, and it made sense. and it was extremely bureaucratic and never really worked right. We spent hundreds and hundreds of thousands of dollars. I'm sure it went up into the millions, and I wouldn't even like to try to figure out exactly what it cost us. But the final result was just more and more bureaucracy, more paperwork, and it wasn't simple. What we're finding now is that we can cut out all of that in our day-to-day motions, and the most important question to ask is, how can we do something more simply? How can we cut out time that we spend? How can we cut out work? And we have to keep asking that question again and again and again. And we have something nice and solved, we need to go back to it again and ask the question, how can we simplify it farther and farther and farther? Now the computer is still necessary, but what we're finding is it's important to have the computer do the things that are important to do. What we were doing before was we were making the system that we had very efficient, so we were making waste very efficient with the computer. Now what we're doing is addressing what really needs to get done and only using the computer system where it really makes sense, which is like in our raw materials planning. That's a very important place for the computer to assist us, but we don't need the computer to be generating paperwork, you know, stacks and stacks thick to tell us what to do all of the time.